Single variable calculus at Wickerson Studios with Michael Wickerson in Grasshopper. I think you'll find it interesting. Basically, I'm continuing to keep my XY axis real lines in the vertical and horizontal positions. And from that, I am grafting a couple of different graphs. Here's the first one, y equals x, and the next one, of course, is y equals x squared. There are some great visuals on here if you want to grab them. And they're all parametric to these points. And I may build them from scratch, but I think I'll just walk you through instead. So this is one that you can play off of and change, and it snaps nicely, and that is the y equals x curve. So you can quickly set it to 1 and know that the square root of 1 by 1, which is root 2, is 1.414214, continue. It's a little cluttery because I have both scripts on. You can take off one and have the other one on. You can just choose this one to be on, and there you're only seeing what's running in that one. And if you hit select on here and choose this as well, then you can see the whole graph as you go, and that is fully parametric to where you want to take that. And that will move according to x and y, and it will show you in two positions. Interesting, I didn't take the other one off. It shows you the distance of that line. What's interesting about this is a straight line, so you can break it into points and think of it as a 2 points and the distance between them. Or you can think of them as several points along that line, and the distances added up between each of those sections. That's going to come in very handy as we start to think about calculus and move into this framework. If we go to this framework, and I think what I'll do is put the whole thing on, not bother with the linear equation, which is available on GitHub through my Patreon. Let's disable that one, and let's leave on all of this nice jazz here and see what exactly is happening to find the length of that curve. Well, it's using calculus, and I will show you a fine example of that. So not only do we have our entire grid on, let's just leave that here. Let's focus in and see what's actually happening to actually make this grid. And of course, it's fully parametric, that I could take that parabola and bring it right down to almost nothing, and then all the way up. And we're getting a length, but we're getting a calculated length of what that curve would be between this point all the way down along it, all the way to that point. These two end vectors are only indicating that that's the direction at that point, tangent to that curve at that point. So what I've done differently than all the other scripts is I look at my data as I go through. I not only am bringing, I wanted to bring a range, and I brought a range in through 10 steps. And I'm not visualizing all those steps, but I could go in, and what I'm going to do is just ungroup this because it makes easy showing. If I showed that entire, sorry, I didn't mean to group it, I meant to show it. If I preview that, you'll see, hang on, preview on, you'll see all those points are basically building lines in a polyline. And as I take a look and bring that down, you'll see the polyline that I'm generating is basically telling, it's adding up the distance similar to how it added up the length of the line, and then it's adding those together. Now, I'm not finding the length of the polyline. I'm actually finding the length of an interpolated curve, which is like us taking this up to a massive count of points right here. And you'll see that that's the estimate between this point to this point, this point to this point. That goes on kind of infinitesimally, if that's the word, till the point that we're actually finding out the infinite amount of pieces between that as it goes to its limit of getting closer and closer and closer. But then what are those distances added up? And that's a great visualization of what calculus is. I'm going to keep the count very low because then I'm able to take those points, put them into a polyline, which is helpful here, these two lines, but I actually have a polyline set on here. I'm not sure where I put it. I thought I had it here. Oh, I brought it over here. So we can actually visualize that polyline in its segments as it estimates. Now, this would have a different length, the polyline curve, if I actually had to add them all up, the sections of it. But that's not the one I want. What I want is this curve. And that curve is doing what the interpolated curve would do. And what I did was just did a little data visualization afterwards at the quarter of the way through the curve, halfway through the curve, 3/4 of the way through the curve, and then at the midpoint of the curve, I think I just have a point to look at, which would be, what did I do at the middle point of the curve? I think I put some text there. I didn't put any text there. I put anything I want. So it might be nice to say, you know, let's just say something like our first, well, it's not our first, but first calculus magic. Let's just call it that, just for fun, so you know where that's going to show up. Let's just take our first calculus magic and put it in here, and there it is, and we'll just do a little justification to the top left, to the top left, and there it is, our first calculus magic. And maybe because it might not be our first, if you actually think theoretically in what we're doing, let's just call it the calculus magic of using that curve. So a fun little exercise in all the things I'm doing. I'm calling it length now as opposed to distance between a point to another point. I'm actually estimating the length of that function, y equals x squared. And I'll let you kind of run that as it is. I've evaluated 2 points, similar to what I was doing with curves earlier, and I'm visualizing those vectors at both points. You can get a little bit into actually how I'm reversing doing the negative of that vector, and I'm actually using a little bit of it's all single data. I don't think there's any list in here. There might be a list in here of something coming out of here from the points, the multiple points, whereas I'll actually grab a list item, so I'm only grabbing one, so I don't have to look at all of them, just the endpoints, what we're dealing with. And once again, you've got a very interesting script. I could build it from scratch if people are interested. Just ask me to do that. Otherwise, this is available on my GitHub through a private repository, which I send out to my Patreons. And you can have a little bit of fun play here and start to visualize and think about what you're doing. This is, of course, going to get interesting because we'll move into x squared plus y squared equaling a coefficient or just a base integer. And then we'll actually explore a little bit about area, and what that actually implies is the area under a curve. So think of the area under a circle curve is actually the area contained within that curve. And we're getting very close to functions. And as soon as we get through the functions of this first chapter, we're going to be hard into differentiation and integration to start doing things with these magic lines to build some beautiful geometries. I'm trying to keep things very simple to start. I'm very excited about this practice of this one. Let's group it. And let's just grab the other one on, because that was a pretty interesting one as well, the graph at y. Take that to enable. And let's play around with the fact that we can have some pretty cool sliders in here playing off of what we're doing with that ellipse. Well, what am I? Why did I just call it ellipse? Parabola, and also, probably because I'm eager to get onto ellipses, and then also onto just the straight line, the linear point of what's happening. But I wanted you to realize the connection between what's actually happening between these points. I have to leave this to get that to visualize. Thinking of the amount of points that I'm putting in here, which is only one between two other points, so I can just average the length. I think I actually had a curve that was made up of multiple points anyhow, but those are the points at each end of that line, and you can break it. Obviously in a line you just can take the endpoints and you can estimate it, or you can come from the center, but it gets a little trickier when you end up jumping in here and you have to think about how many points are actually making up the curve. So that's really the conceptual side of what I wanted people to start recognize the importance to do, and what's actually happening in the sense that it's hitting its limit of having an infinite amount of points within this curve, and what we're actually adding together to calculate through calculus the length or the distance between one point to the other point following that curve. I like the quote within this book that the Greeks simply saw lines and curves as the paths that points were taking as they moved. So you get into the sense of what it really is about. So enough said. Pretty beautiful stuff. Pretty nice diagrams. Nice things to play with and visualize. If you can script in this, and I just wanted to move a little bit of data back so I don't have that coinciding with that other data. And of course, if you have multiple scripts going on top of one thing, you can run into double images. And we are tending to want to make stuff out of this. So if we actually grabbed all this and hit bake, we've actually, I don't know what just happened like crazy. Our text just went through the roof. Baking it, that's pretty interesting. I never knew that would happen. I'm going to select this text and get rid of it. Oh my gosh, never knew that would happen. Let me get rid of these text objects. You find something out a little bit every time you do something. I just want to select all these text objects and get rid of them. And then we've got this baked form. This is actually a hard geometry in Rhino. And of course, it's hard to see, but you can technically select it all. It's like you static model this entire chart. But what's the power of Grasshopper is that we can fully make that parametric. We can jump in here, have our original one that we were looking at, and start to translate that and bake it wherever we want. So you actually build some pretty cool graphs and visualization for your courses. I will say that I'm interested in this because of, that one's not so interesting because it's just staying along the other line, but you have baked in all these other texts that are there. I don't mean to make a mess of things, even though I have a tendency to do that, and I didn't mean to complicate up this because we're estimating the length of those lines. I'll probably leave it in here as the steps and let you play with that if you watch this video. Let's save it to 010 at coordinates and graphs, and like I said, that'll be available online. Thanks very much for watching. I'm excited to get into the areas and circumference of circles.